Okay, I hope I'm audible to all students who are attending this lecture of Introductory Microeconomics. We continue with our lectures on consumer theory. We continue with our lectures on consumer theory. Formally, this is chapter 21 of the book which I prefer to follow for the Introductory Microeconomics course. This is Gregory and Mankiw. Okay, and the edition which I will be following is the 4th edition. Okay, so all of you can recall in the previous lecture of consumer theory, we were doing the concept of indifference curves which capture consumer preferences, and we had also done the properties of indifference curves in depth. Okay, now in this particular lecture, we intend to look at special cases of indifference curves. We intend to look at special cases of indifference curves. Okay, and since this is the introductory microeconomics course, I will be doing only the 2 special cases. However, in my intermediate microeconomics course, I will be talking about more cases of consumer preferences and their corresponding indifference curves. So since this is the introductory microeconomics course, I intend to do only 2 special cases. However, in my advanced or intermediate microeconomics course, I will be touching upon more special cases. So one special case of consumer preferences called perfect substitutes. Perfect substitutes. Okay, so this is one special case of consumer preferences. So guys, when are 2 goods said to be perfect substitutes? So we can write 2 goods are said to be perfect substitutes. 2 goods are said to be perfect substitutes if they can. 2 goods are said to be perfect substitutes if they can be consumed in place of each other. So 2 goods are said to be perfect substitutes if the consumer can consume them in place of each other. Another way of saying it is, when are 2 goods said to be perfect substitutes? 2 goods are said to be perfect substitutes if the rate of exchange between them is a constant. So I can say that is the rate of exchange between them. The rate of exchange between them. And what is the rate of exchange called? The rate of exchange is nothing but MRS, the marginal rate of substitution, is constant. So guys, we say that 2 goods will be called the perfect substitutes of each other if the consumer trades one good for the other at a constant rate. Other way of saying it is that the MRS, which is the marginal rate of substitution between both the goods, is constant. Okay, so let me take an example. For example, suppose I have 2 commodities, X, suppose X stands for Coke, and suppose Y stands for Pepsi. Now, assuming that the consumer is not any brand follower, okay, assuming that all what the consumer wants is a soft drink. Now, suppose the consumer prefers to consume 10 soft drinks. Suppose I can write the consumer prefers. Suppose the consumer prefers to consume 10 soft drinks. And you can see the soft drinks here are Coke and Pepsi. Now, what all bundles can we have? You give the consumer 0 Coke with all Pepsi. You give the consumer 1 Coke with 9 Pepsis. You give the consumer 2 bottles of Coke with 8 bottles of Pepsi. You give the consumer 3 bottles of Coke with 7 bottles of Pepsi. 4 bottles of Coke with 6 bottles of Pepsi, 5 bottles of Coke with 5 bottles of Pepsi, 6 bottles of Coke with 4 bottles of Pepsi, 7 bottles of Coke with 3 bottles of Pepsi, 8 bottles of Coke with 2 bottles of Pepsi, 9 bottles of Coke with 1 bottle of Pepsi, 10 bottles of Coke with 0 bottles of Pepsi. All these bundles give the same satisfaction. All these bundles will give the same satisfaction to the consumer. Okay, all these bundles are going to give the same satisfaction to the consumer. Why? Because assuming that this consumer is not any brand follower, all he wants are soft drinks. If there are 10 soft drinks he prefers to consume, you can give him 0 Coke with 10 bottles of Pepsi, or 1 bottle of Coke with 9 bottles of Pepsi, or so on. All these combinations will give the same satisfaction to the consumer. So guys, if you plot them, how will they look like? So if I erase the initial part, we know the topic now. So if I erase the initial part and if I erase the definition of perfect substitutes, and let us try to plot these bundles in a graph. So erasing all this, let's plot these consumption bundles in a graph, and let's see what do we get. So let us draw a diagram. So on your screen, you can see that on the x-axis, we are measuring Coke, and on the y-axis, we are measuring Pepsi. Now 0, 10 would be somewhere here. Okay, this is 0, 10. 1, 9 will be somewhere here. This is 1. So I can label it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On similar lines, 1, 2, 3, 4, 5, 6, and I can stretch it, guys. I can stretch it further. Okay, I can stretch it further. 7, 8, 9, and 10. Okay, so how do I plot 0, 10? This is 0, 10. This is 1, 9. This is 2, 8. This is 3, 7. This is 4, 6. This is 5, 5. This is 6, 4. This is 7, 3. This is 8, 2. This is 9, 1. And this is 10, 0. Okay, this point is 0, 10, and this particular point is 10, 0. Now, if I join all these points, what am I getting? You can clearly see my indifference curve is nothing but a straight line. Now, guys, I'm not using any scale. So since I'm drawing it on the screen, geometrically, it might not come out as exactly accurate because I'm not using any scale, but it's somewhat like this. So this is my indifference curve for perfect substitutes, because all these bundles are giving the same satisfaction to the consumer. All these bundles give the same utility or same satisfaction to the consumer. And what will be the MRS in this case? How do we find the slope? My MRS, very simply, which is nothing but the slope of the indifference curve, is nothing but change in y by change in x. Now, very simple. Suppose I move from 0, 10 to 1, 9. What will my change in y be? 9 minus 10, new y minus old y upon new x, which is 1 minus the old x, which is 0. So what will be the slope, guys? Minus 1. So I can say these are indifference curves for perfect substitutes with MRS equal to minus 1. Between this and this, you can calculate MRS. Again, it will come out as minus 1. Between this and this, you calculate MRS. Again, it will come out as minus 1 and so on. That means the rate of exchange between Coke and Pepsi in this example is a constant. For every one bottle of Pepsi I am giving up, I am getting exactly one bottle of Coke. So my rate of exchange is a constant. And guys, I want to point out, it is not necessary that MRS has to be minus 1. It can be minus 2 also, it can be minus 3 also. So please do not think that in case of perfect substitutes, MRS has to be minus 1. No. It is not compulsory for MRS to be exactly minus 1. What is compulsory is, in case of perfect substitutes, MRS should be a constant. So I can write a note here. Okay. In case of, I can write in case of, okay. In case of perfect substitutes, MRS must be a constant. But please do not think that it should be equal to 1 only. No. It can be minus 2, it can be minus 3, it can be any constant number. It can be even in fractions. It can be minus 1.5 also. So MRS must be a constant. So it is completely possible that you can give up one bottle of Pepsi for 2 bottles of Coke. In my example right now, I have taken a case where the consumer is giving up one bottle of Pepsi exactly for one more bottle of Coke. But it's completely possible that the consumer gives up one bottle of Pepsi for 2 bottles of Coke. So understand this. What is important is that in the case of perfect substitutes, MRS must be a constant. It may or it may not be equal to 1. It may or may not be equal to minus 1. Why is the MRS minus, guys? MRS is minus because indifference curves are downward sloping. Any line which is downward sloping will always have slope which is negative. And MRS is the slope of the indifference curve. So I hope students have understood this. Okay. And similarly, guys, we can talk about the second case. The second case of special case, perfect complements. Perfect complements. Okay, so when are two goods said to be perfect complements? So we can say two goods are said to be perfect complements if they are consumed together if they are consumed together in a fixed ratio. Two goods are said to be perfect complements if they are consumed together in a fixed ratio to satisfy a want. So when you are consuming two goods together in a fixed ratio, it can be 1:1, 1:2, 2:1. In general, A is to B, where A and B are fixed numbers. Okay. So when you are consuming two goods in a fixed ratio to satisfy a want, the two goods are said to be perfect complements. Let's take an example, guys. For example, suppose I have two goods, left shoe. Suppose this is my good X and right shoe. Now this is a classic example of perfect complements. More examples: tea and sugar, car and petrol, pen and ink. These are all examples of perfect complements. But a classic example is the left shoe and right shoe. Obviously, when you buy shoes, you buy them in the ratio 1:1. For every one left shoe, you always buy one right shoe. You always buy shoes in pairs. Okay, so how will the indifference curve look like? So if I draw the diagram for this, on the x-axis we measure the left shoes, and on the y-axis we measure the right shoe. Now guys, let's plot the indifference curves. Okay, suppose let me consider a combination of 5 left shoes and 5 right shoes. So I am at this point which consists of 5 left shoes and 5 right shoes. Now if I ask you, if you buy 5 left shoes with 6 right shoes, will it give you more satisfaction than 5,5? If you go to the market to buy 5 left shoes with 6 right shoes, will the 6th right shoe give you any satisfaction? No, it will give you the same satisfaction as 5,5. Similarly, if you go to the market to buy 6 left shoes with 5 right shoes, will it give you any satisfaction? No. Why? Because the additional left shoe gives you no satisfaction without the right shoe. That means, guys, all these 3 bundles will give you the same satisfaction. That means if I go to the market to buy a pair of 5 left shoes and 5 right shoes, whether you buy 5,5 or you buy 5,6 or you buy 6,5, all 3 are going to give the same satisfaction. That means all these 3 points should lie on the same indifference curve. So if I join them, I get the indifference curve for perfect complements. This is my indifference curve for perfect complements. Okay, this is our indifference curve for perfect complements. You can clearly see that these indifference curves are at right angles. Okay, so in this particular case, now this is called the kink. All of us know in mathematics what is a kink. A kink is a sharp or a rough point. It's a sharp point. In mathematics, all of us know that a kink is a point which is not differentiable. You cannot differentiate the function at the kink. It's a sharp point. Okay, so if you look at MRS, or if you look at the slope of the indifference curve, what will be the slope of the indifference curve on the horizontal portion? So what will be my MRS on My MRS on the horizontal strip. Horizontal strip is this strip, horizontal strip. What will be my MRS on the vertical strip? And what will be my MRS at the kink? So guys, what will be my slope on the horizontal strip? This is my horizontal strip. This is my vertical strip. And you can clearly see the kink. Now, in mathematics, we know this very well that any line which is parallel to the x-axis has slope equal to 0. Any line which is parallel to the y-axis has slope equal to infinity. And we just said that a kink is not differentiable. Since you cannot differentiate the function at the kink, MRS is not defined at the kink. MRS is not defined at the kink. Okay, so what we have learned is, guys, in case of perfect complements, my indifference curves are at right angles. So we can say that perfect complements are defined as, goods that have indifference curves at right angles. They have indifference curves which are at right angles. Okay, so I hope students have understood this special case. So this was a case when you are buying left shoe and right shoe perfectly in the ratio 1:1. The ratio here was 1:1. Why? Because you never go to the market to buy one left shoe with two right shoes. People will laugh. You always go to the market to buy one left shoe with one right shoe. But in general, it is again not necessary that for every case you will have 1:1 ratio also. For example, people usually have 1 cup of tea with 2 teaspoons of sugar. So your ratio has to be fixed, but it will not necessarily be 1:1. Students need to understand this. In perfect complements, your ratio has to be fixed every time, but it will not necessarily be 1:1. It can be A:B in general. So I hope all students have understood this. And guys, if I sum up, what we have learned for perfect substitutes and perfect complements is as follows. So in case of perfect substitutes, our indifference curves are downward sloping straight lines. Good X, good Y. Our indifference curve, this is one indifference curve I've drawn. They are downward sloping straight lines. And guys, higher indifference curve represents higher level of satisfaction. So this is IC1. Then I can have an even higher indifference curve, IC2. All these have the same slope. So they are all parallel to each other. All these indifference curves have the same slope. They are all parallel to each other. Okay. And I can say that ICs are downward sloping. They are downward sloping straight lines. Our ICs are downward sloping straight lines. And MRS is a constant. ICs are downward sloping straight lines and MRS in this case is a constant. Okay, and in the case of perfect complements, what we have learned, Okay, in the case of perfect complements, if I plot the indifference curves, again this is our origin, good x and good y. Okay, two goods are said to be perfect complements if they are consumed in a fixed ratio. So this is one indifference curve. Again guys, higher indifference curve represents higher level of satisfaction because of monotonic preferences. So this is IC1, IC2, IC3. Okay, you can clearly see that once you are on a higher indifference curve, you get higher level of satisfaction because a higher indifference curve consists of more of both the goods. So in this case, my ICs are at right angles. ICs are at right angles and L shaped. You can see they are forming an L. Okay, and these are all my kinks. So I can say these are all called kinks. Okay, and what we have learned is MRS on the horizontal strip. MRS on the horizontal strip is 0. MRS on the vertical strip is infinity, because any line parallel to the x-axis has slope 0, any line parallel to the y-axis has slope infinity, and MRS at the kink is not defined because a kink is not a differentiable point. The function is not differentiable at the kink, so my function is not. So I hope students have understood the case of perfect substitutes and perfect complements. Okay. So now what are we doing? Now we are looking at the consumer's optimal choice. So now guys, we come back to the normal case of convex indifference curves and downward sloping budget lines. We have done the extreme or the special cases. They are over now. So now we look at consumer's optimal choice. We now look at the consumer's optimal choices. Okay, so now when we look at consumers' optimal choices, we are now going to combine affordability plus preference. When I combine affordability plus preference, this will give me the demand. What the consumer will demand will depend on both his affordability and his preference. Now, affordability is captured by the budget lines and preferences are captured by the indifference. So if I draw a diagram, if I now have both budget lines and indifference curves in my diagram, so you can see this is good X, this is good Y. We have one budget line. For a consumer, you cannot have more than one budget line. You obviously have one budget line at a point of time. Okay, all of you can recall this was my horizontal intercept M by Px, where M denotes the income of the consumer. This is my vertical intercept of the budget line M by Py, and the slope of the budget line is minus Px by Py. All of you can recall this from my lectures on budget lines in consumer theory. And then guys, we have family of indifference curve. So this is one indifference curve. This is another indifference curve. This is another indifference curve. I can draw a family of indifference curves called the indifference map. So suppose this is I0, this is I1, this is I2, this is I3. These are all indifference curves. Now we want to look at what will the consumer afford? What will the consumer demand? Now, affordability of the consumer is given by the budget line. Preference of the consumer is given by the indifference curve. Now, we want to see what will the consumer actually buy? What will be his optimal choice? So, I ask you, Can the consumer buy any bundle on the indifference curve I3? Not possible. The consumer cannot buy any bundle on I3 because it lies above the budget of the consumer. Can the consumer buy any bundle on the indifference curve I2? No, because I2 lies above the budget. Any indifference curve which lies above the budget is not affordable. If it's not affordable, you can't buy it. Even though you want to buy it, but you cannot buy it because it is beyond your budget. So guys, there are only two indifference curves which are within the budget, I1 and I0. So clearly from the above diagram, there are, or I can write clearly from the above diagram, the consumer cannot buy any bundle on the indifference curve I2 and I3 as they are beyond the budget. As they are beyond the budget of the consumer. The consumer cannot afford them. The only indifference curves, the only ICs within the budget, the only ICs within the budget are I0 and I1. Now we can take 2 points. Suppose this is point A, this is point B, and suppose we say this is point E. Now, will the consumer want to buy A and B? No. Why? Because the consumer can buy E and be on a higher indifference curve. So clearly, even though bundles A, B and E are all affordable, even though bundles A, B and E are all affordable, the consumer will prefer only bundle E. The consumer will prefer only bundle E. Why? Because it lies on a higher indifference curve compared to bundles A and B. You can clearly see bundle E lies on a higher indifference curve I1 as compared to bundles A and B which lie on I0. So I can say therefore bundle E is the only bundle which the consumer can afford and prefers to consume. Therefore, E is the point of consumer equilibrium. E is the point of consumer equilibrium or the optimal choice of the consumer. Bundle E is the optimal choice of the consumer, which corresponds to X1 star of good X, and I can say X star amount of good X and Y star amount of good Y. Okay, so what we have learned is that mathematically the consumer's optimal choice is given by the point at which the indifference curve is tangent to the budget line. So guys, if I write this point, so erasing this off, I am erasing the initial portion. I hope students have written this and they have understood this. So let's talk about it mathematically. We have talked about it diagrammatically. We have explained the diagram. Let's look at the mathematical point of view. So mathematically, the optimal choice of the consumer, is given by the point, at which slope of the indifference curve is exactly equal to slope of the budget line. I can write one more line. It is given by the point at which the indifference curve is tangent to the budget line. Is given by the point at which the indifference curve is tangent to the budget line, which means that slope of the indifference curve is equal to slope of the budget line. Now, mathematically, if a curve is tangent to a line at a point, then at the point of tangent, slope of the curve exactly equals the slope of the line. So this implies, what is the slope of the indifference curve? In absolute terms, it is MRS. And what is the slope of the budget line? In absolute terms, it is Px by Py. Guys, let's ignore the signs, because MRS will also be negative, Px by Py will also be negative, because budget line and ICs both are downward sloping. So we look at their absolute values or their positive values. So the point of optimal choice will occur where the indifference curve is tangent to the budget line. That means when the slope of the indifference curve exactly equal to the slope of the budget line. Now slope of the indifference curve is marginal rate of substitution, and slope of the budget line is Px by Py. So this is my necessary condition. This is my necessary condition for optimal choice. So hoping that the students have understood this. And guys, then we have the sufficient condition. This was the necessary condition for optimal choice. My sufficient condition is that MRS should be diminishing. MRS should be diminishing. As we move from left to right, along the indifference curve. And you can see from the properties of indifference curves which we had done, you all can recall that as we move from left to right along an indifference curve, MRS is diminishing. What does this mean? As you keep on consuming more of good X, you are lesser and lesser willing to sacrifice good Y every time. Because if you can recall from my previous lectures, if you start losing any good, it's important, it grows in importance for you. So when you start sacrificing good Y, it becomes more important. So you are lesser and lesser willing to sacrifice it for every additional unit of good X. That means MRS is diminishing as we move along an indifference curve. So this is my sufficient condition for consumer equilibrium to happen. For the consumer equilibrium to be unique, remember guys, you will only have one equilibrium only when MRS is diminishing. That means your indifference curves are strictly convex. Okay, and your first condition is the necessary condition. Your indifference curve should be tangent to the budget line, which means the slope of the indifference curve in absolute terms, which is mod of MRS, should exactly be equal to slope of the budget line, which is Px by Py. Okay, so hoping that all students have understood this and have no doubts. Okay, so this is where I intend to stop in this particular lecture. Okay, we will now look at what will happen to the consumer's optimal choice when income changes or when price of any good changes. So we look at the impact of these changes on the optimal choice in the next lecture of consumer theory. So this is where I intend to stop in this particular lecture. I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or you can call up, or you can mail me your doubts at the following email ID. You can mail me your doubts at the following email ID. So this is where I stop in this particular lecture.